All right, so we just calculated the theoretical probability that a point chosen at random is going to land inside of this purple area, and it was exactly pi over 4. That's the theoretical probability calculated geometrically. But remember, our goal here is actually to evaluate or actually approximate the value of pi. We're trying to see where this whole 3.14 business comes from using something called a Monte Carlo method, which has to do with probability. So that brings us to our exploration. We're going to do a little experiment here. And we want to use a collection of non-magical beans. If you have magical beans instead, you can use those, I guess, but they might jump around on you. And I do recommend lentil beans if you have those hidden in your pantry. And we're going to find the experimental probability that one of your beans are going to land inside the shaded region. And we're going to use that to approximate the value of pi, as we'll see here in a minute. So to start this little activity, you need a box. And so your box is a printout. It looks sort of like this, right? So you're going to cut along these bold lines here. All the bold lines you're going to cut out. This is the bottom of the box, and you can see this is the exact same shaded figure. I know it's a different color. It's gray. I hope that doesn't affect the probability. So this is going to be the bottom of the box. We cut all of the bold lines, and the dotted lines are all going to be fold lines, okay? And then we look at the other page, and the other page is the top of the box, and likewise, we're going to cut on bold and fold on the dotted lines. And I'm going to suggest that you use about 30 beans for this, and you're going to do 5 different trials. And you're just going to get some sort of ratio, right? It's the number of beans that land inside of our, in this case, gray area here, count them up, out of the total number of beans. Maybe it's something like this, 25 out of 30. And you're going to carry that out 5 different times. You got to be pretty careful whenever you shake up your beans and you shake up your box, though, that you don't just shift it to one side or the other, because then all your beans are going to go in one direction. You want to try to keep it as flat as possible. All right, and then how is this supposed to end up with the value of pi? Let me show you another little picture here. So this is the experiment being carried out on a computer, and we're certainly not going to do this many trials, but look at the value of pi getting possibly a little closer to 3.14 over and over in that little animation. So let's see how we're going to get that particular number. So we calculated the theoretical probability of a bean landing in a shaded region as pi over 4. So I'm just going to rewrite that. This was the theoretical probability, and it was a point, but we're going to use beans for this, so I'm going to say bean in shaded region. That should be equal to a pi over 4. Exactly. Experimental. Not experimental, theoretical. Sorry. Ooh. So notice that we have a pi in here, right? There it is right there. And it is an equation. We have probability equals and then pi over 4. And I can solve that equation for pi by just getting rid of this 4. 4 is being divided into pi. To get rid of it, I'm going to multiply. So I'm going to multiply both sides of this by 4. And of course, over here on the right side, they cancel out, leaving me with pi, which is what we want to try to find. So 4 times the probability of a bean in the shaded area should be exactly equal to pi. Now, if we use the theoretical probability here and multiply it by 4, we'll always get the number pi. But what we are going to do is conduct this portion of it experimentally. And remember, when we're talking about experimental probability, when we started out in our number of trials, like rolling a die or flipping a coin, it doesn't exactly match up with the theoretical probability. So ours is not going to completely match up with this value, actually pi over 4, until we start doing more and more trials. And the more that we do, the closer and closer we should get to pi over 4. If we multiply that thing by 4, it gets rid of the 4 that's over here on the right-hand side, and it leaves me just with pi. So basically, here's the setup. I shake my beans, I shake my beans, and I shake my beans, and I count them up, and whatever I get After all of those trials are conducted, we multiply that thing by 4, and we should be getting closer and closer to pi the more times that this experiment is carried out. So what we will do when we come back to class is that we'll count them all up. We'll collect all the data from everybody that carried out this experiment, and we're going to see how close we can get to the true value of pi, how close can we get to 3.14159, and so on.